Hello, everyone. You are welcome to another episode of AI for Humans, and we are at episode 9. And we are going to be discussing the neural networks. Last class, we were able to talk about reinforcement learning and how AI is able to, more like in a game mode, able to remind itself of what it does right and what it does wrong. And the beautiful part of this is once a behavior is reinforced as positive, it helps you to be able to further improve on those type of answers. You could check out the last video on episode 8 on how we actually established this. But this week we said we're going to go deep into the brain, right? What exactly is the working factor that makes AI behave the way AI behaves? And in this episode, there's going to be a couple of math tricks. I'll explain it very simply, but I need to get a bit technical for you to be able to understand how neural network works. But don't worry, I'll walk through it. Now, for this episode, neural networks is a topic, but you see I wrote 86 billion. 86 billion. Well, something around that. These are the number of neurons in your brain working right now. Think of them like wires that pass information, simple processors. So if you have the brain, and this is not a very good representation, but get it. Okay, so you have your brain. Inside the brain, there is one neuron connected to another neuron, which is connected to another neuron, which is connected to another neuron. And this neuron can be also connected to 4 more neurons. It's a very complicated thing that goes around in the brain, but no biggie. Now, scientists decided to ask a very dangerous question in the 1940s. They said, what if we built something, a machine, inspired by the brain? It's not as complex, it's not a biological system because the brain is so complex that building something that does exactly what it does has to be God mode. So we're like, let's look for connected nodes that pass signals to each other. And that became the neural network. That is what changed machine learning. That is what gave birth to AI today. So let us start with one artificial neuron. And once again, remember that the aim of the playlist is to give you a lot of intuition. The way the neural network works is that there is, you can call this the brain, an input signal and then an output signal, right? In here is where there's a lot of computation done. So I want you to think of this as the computer. And what happens is when you send information, which is data, to the computer, computer processes it and brings you out your output. Simple, straight. That's the way it has always worked, right? Okay. Now, think of it in the terms of how the neural network works. It takes in several inputs. It takes in several numbers. And remember, we said that each number has a weight. Each input has a weight. So remember episode 4, we did something where we explained the concept of the neural network with a question. And we asked ChatGPT, who is a boy? So I want you to pay attention to the fact that everything you input into ChatGPT is sent to that machine that works as a neural network. So think of it like this. ChatGPT here is the processor, and your question, who is a boy, is sent to it. Who is a boy, sent to it. And then it would output the answer. A boy is whatever, right? And for each of these inputs, there are weights. I remember we discussed in episode 4 where we said the weight of boy may be 0.6, the weight of A may be 0.2, E 0.1, U 0.4, blah, 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 blah. There's a lot of math in this. I don't want to get into that. I just want you to understand that the stronger the weights, the more the input matters. The stronger the weights, the more the input matters. Now, let's do a little bit of X and Y for you to get the idea here. Let's imagine that we have an equation that says, and if you didn't like math, this wouldn't be too crazy, but let's say 2x plus 1 is equal to y, right? What we are saying is whatever value y will become, x is going to determine that. Why do we say so? Because if I come here and I say x is equal to 0, 2 times 0 plus 1 will be equal to what? That's 0 plus 1, 1. Y becomes 1. However, if I come here and I say x is equal to 1, 2 times 1 plus 1 will now be what? 2 times 1, 2 plus 1, 3. Y becomes 3. And if I change it and I say x is equal to 2, 2 times 2 plus 1 will now be what? 4 plus 1, 5. Y becomes 5. Think of x as the weight. If the weight is high, the output is high. If the weight is low, like a 0, the output is low. Now, the neural network multiplies every input by its weight. In episode 4, we explained that each number, each letter, everything you passed into your machine, into your computer, has to be converted into a number. So think of it like this. And once again, we're not going to get too technical, but if my question to ChatGPT is, who is a boy? As we asked earlier, who is a boy? When you send it, there is a processor in your computer or in ChatGPT system that converts this statement, who is a boy, into a set of numbers, maybe 0.412, 0.86, 0.95, 0.2. This is oversimplifying it, but this is what happens. Your text becomes numbers, call them vectors. And then what happens is we pass these vectors into the system. This is your question, actually. And these vectors are passed into the system, which in this case, we would now call neural network. So it will be passed into that system. Let's call this the system. And that system is going to give us an answer. But for that system to give us an answer, each of these vectors has to be multiplied by a weight. And remember, we said the model holds the weight. It understands the connection between words. So when we pass 0.412 here, let's call 0.412x. Let's call 0.86y. Let's call 0.95z, 0.2w. When we pass it, passing it is you have sent your question, right? So it's like you're passing it to the processor, and the processor now looks inside the model. So the processor will now go and check the model. This x, what is it connected to? What are the words that x is connected to? What are the words that y is connected to? What are the words that z is connected to, w is connected to? And then we'll do simple algebra, which is not simple in complex terms, but it's more, this is the idea of what's going on in there. So let's say the weight of x is 2, the weight of y is 3, the weight of z is 4, the weight of w is 5. So we'll say 2x plus 3y plus 4z plus 5w is what will give us our final answer, which in this case will be our output. So let's call it this, right? So this is what happens in the neural network. Now, once again, I agree that this can be a bit confusing to understand. So let us use a very interesting example. This example is going to be long, not super long, but just so that you understand how this stuff works. Imagine if we sent the picture of a cat to a machine and we wanted it to identify if it was a cat or not. Question is, how exactly does it identify that? Remember, we said that everything you send to a machine is converted into numbers. But for now, let's pretend like the machine is actually seeing the picture, right? And so we are sending a picture. But when we send a picture into the system, the picture is not received as a whole, right? So if I send a picture, let's just pretend that this is a cat. If I send a picture, I hope this is not offensive. If I send a picture, right, to the machine, the machine does not take the entire picture as once. No, it takes it as packets. It breaks it down into smaller data sets, smaller data chunks, smaller ones. So think of it like this. The machine will receive the picture like this. So receive this part, to receive this part, to receive this part. It will receive this part too, right? Right. This is how the machine is receiving it. Remember, numbers, but in this case, let's pretend like it's actually receiving the picture. Now, this is the processor here. Then the processor would now collect these pictures and we want it to identify which animal is this. So the processor will look at this, multiply by the weight, look at it again and say, okay, what are the features that I have here? And probably this part here, the cat has pointy ears. The machine, remember the model already knows what a cat should have. So you say, okay, does it have pointy ears? Check. Okay, if it does have pointy ears, that doesn't mean it's a cat. It simply means that we're saying that there's probably a 10% probability that this is a cat, right? So 10 out of what? 100. In this case, 0.1 out of 1. Okay, if it has pointy ears, cats are not the only things, animals that have pointy ears. There are other animals that have pointy ears. Okay, so pointy ears, good signal. Okay, what else do we think a cat has? Then probably we check and we see that the cat has whiskers. Like, oh, it has whiskers. Now, this reinforces, right? It adds to it. I'll be like, okay, if it has whiskers, 0.2. Okay, what else does it have? Then we look and we say, oh, the cat has a tail. Okay, if this animal has a tail. Now, at this point, the processor does not know what animal this is. It is simply taking those features that it finds. It has whiskers, it has a tail, it has this. Then maybe in the picture also, we send, you're sending every aspect of the picture. Maybe there's blue sky in this background. So we send blue sky to it as well. Like, okay, background, there's a blue sky. I'll say, well, blue sky doesn't really, mean anything. So that might just be a 0.005 contribution to it. So we now look at it. Okay, now we have the whiskers, we have the tail, we have everything. Sum it together, right? Add all of this together. So we add it together. 0.3 plus 0.1, 0.4 plus 0.2, 0.6 plus 0.05, so say 0.605, right? And let's imagine that we say, okay, if it scores greater than 0.5, it is a cat, but if it scores less than 0.5, it is not a cat. So like, oh, 0.605, good, this is a cat. Yep, I hope that sums it up. So the inputs, so what we do is for every text, for every picture, and this is how your Google Lens and everybody is finding the answers to your question. When you put in a picture of a dog and be like, what is this? It looks at the picture, it picks out all the features of the dog. Oh, does it have a tail? Oh, does it have a furry skin? What exactly do we have about it? It multiplies, it adds all of those things together, and then it comes back and tells you, oh, this is a dog, right? Okay, so once again, because we didn't go deep into the math, it might not make a lot of sense. By virtue of intuition, you can easily tell anyone that, oh, a neural network that works in artificial intelligence is simply where we input data to the machine. The machine takes that input as numbers, multiplies it with weights, and then it outputs a result. I mean, I think you could get by that, but okay. So yeah, ideally. But we're not done, right? We're still going to go deep into this so that you can actually get a very full picture. Now, let us imagine that we want you to understand is in a very broader form. What exactly is happening under the hood, right? So let's say that what we've been talking about is that we've simply said that for a neural network, there is there's an input, there's a processor, and there's an output. What we call this in machine learning is this part is the input layer. And this part, the processor, is the hidden layer. And this part is the output layer. all connected. So the input layer sends to the hidden layer does the thinking, send its output, its final answers to the output, right? And that's what happens. The more so when we talk about these layers now, what we've said, simply put, is that for each neural network, right, this is the way it works. So again, let's go back to the brain's analogy and understand how this makes sense, complete sense. Why do you react negatively to some things and positively to some other things? Why? And you would see the intelligence in what the scientists did, especially with reference to the neural networks and with reference to the brain. Every day we see millions of people. Okay, maybe not millions. Every day we see at least 20 people, 30 people. If you're the type of person that goes to work, you see a million people or more. And every day you see those people and you are able to easily identify your friends, your co-worker, your boss. How are you doing that? It's because your brain is able to identify what we call physical features. Remember when we talked about the cat, we said the cat has whiskers, it has a tail, it has a lot of this. We look at all of these things and we say, yes, this is a cat. Every time we see a cat, even the brain is doing the same thing. The brain is receiving all of those pixels, all of those information about the cat, and then it is adding it up and it's saying, yes, this is a cat. Same way when you see your friend, you know your friend because your friend probably has long hair, your friend probably has dark skin or is light skinned. You see all of those things and you're able to identify that this is my friend. Why? Because it's pretty obvious. Good. So that's the idea. Is like when we say the neural network is identifying things, it is looking at every bit of information that it has been sent and comparing it with what it already knows. And then when it does that, it is able to tell you if that information is a cat or if it's a dog or if it's this. But what if in a situation where you send an image to the network and you're like, is this a cat? But the answer is no, it is not a cat. Probably it was a dog. Well, we go back to what we did earlier. And if you remember, we said it looks at all the features. So let's imagine that this is actually like this obviously is not a cat, right? So we send it down and then it looks at this. There's a head, but there's no pointy ears. There's a hand, but there's no whiskers. There is no tail. And then it's all these weights will be reduced. So it probably will be like a 0.1, a 0.2, 0.0, right? And then by the time you sum it together, you find out that this is not a cat, right? So that alone is how the system works. That is the brain of artificial intelligence. So I like to always say neural networks were inspired by you, inspired by your mind, the way your brain works. So that is how it's actually able to work with that. Now, here is the important thing to note about neural networks. Remember we said earlier that for the neural networks, it looks at it and it says tail, whiskers, pointy ears. Well, one might ask, okay, how does the neural network know that this is a tail? How does it know that, oh, this is a pointy tail? Nobody sat down for 1 million hours and drew and then give the computer 1 million images of cats. And then for each of those images was now annotating them and saying, this is tail, this is head, this is whiskers. No. This is where we go back to what we discussed in unsupervised learning. So what did we do? They just passed these 1 million images of cats to the system. And what does the system do? The system will now look at those images over and over and over and over and over again and then see similarities. Remember we talked about that? Similarities. So if we pass 1 million images of these cats and in all of these 1 million images, all of them have a tail. What does that tell the system? Cats have tails. We pass all of them and all of them have whiskers. All of them have whiskers. All of them have whiskers. That tells it that what? Cats have whiskers. We pass all of them and they all have pointy ears. That gives it new information. That gives it new information. These are the things that form the weights because, like we said, reinforcement. So if it sees the same thing over and over and over and over again, probably when it saw the first image, it was like, okay, whiskers maybe 0.1. But when it sees whiskers 1 million times, it will probably give it 0.8. Right? Good. So now what is going on here is that when you bring in your system and you come and you say, and let's say, okay, after all the training, it says whiskers 0.8. So whiskers 0.8, pointy ears 0.7. Let's say, what else? The tail 0.6. Any animal that has all of this is equal to cat. So this is why when you go on Google and you say, and you input the picture of a cat, and once again, this is only working like theoretically in principle. It's a lot more complex in code. I like to always indicate that. So let's imagine that we pass the image of a cat. I know, right? And this is the tail. We pass this image into the system. The system then does this. The system now looks, it says, okay, if the system sees pointy ears, remember that we already converted this to numbers. Okay, we converted it to numbers. So by after we converted it to numbers, pointy ears in the numbers was just 0.2, right? If the pointy ears here, after converting to numbers, the pointy ears were 0.2. And the tail, we assigned it a number 0.15. And then the whiskers, we assigned a number 0.3. When we convert it to number, right? There's a machine that does that. It converts it to numbers. So what we will now do is, before we send it here, we'll now say, what is then the processor will look inside the model. So this is the model it's coming to now. Say, what is the weight for whiskers? Whiskers weight 0.8. So we come here, we multiply by 0.8. Then it goes again. Did I see tail? Oh, yes, I saw a tail. What is the weight for the tail? 0.6. And then it goes back again. Did I see pointy ears? So like, yes, I saw pointy ears. And pointy ears are in our model, so we multiply this by 0.7. After we do all of this multiplication, actually, we could do that. So I think 0.2 minus, multiplied by 0.7. We're going to multiply all of that just so you get, once again, an idea. 0.7, and we say, okay, this is 0.14, and then 0.15 multiplied by 0.8, and that should give us, just a moment, just so we get it right, 0.12, and then we say 0.6, and nobody converted this number, so please just bear with me trying to make examples here. Okay, 0.18. So if we add all of this together, and this is what's happening in the processor is multiplying, adding all the multiplied values together. So if you multiply this now, 0.14 plus 0.12, we get 0. So we get 0.44, right? Now, in data science, there's a concept we use where we say, okay, if it has crossed this threshold, it is a yes. If it has not crossed that threshold, it is a no. So let's imagine here that our threshold was 0.5, right? If the threshold is 0.5, we are automatically saying this picture is not a cat. Now, this might be good because what we might be looking at here might not be a cat. It may be a cheetah, right? It may be something else that just has all of those features of a cat, but the machine is so intelligent that it has studied so many pictures and it knows. Or on the wrong offside, we might be looking at the picture of a blurry cat. And because the picture of the cat is blurry, by the time we convert it to numbers, those numbers are not as strong as a bright picture of a cat. So once again, the point is, I hope you've been able to get intuition as to how this works, right? How this works. So the power of neural networks is we build them, we'll build the network, we'll train them, and then one other aspect is that we don't always understand how the neural network is able to find its answers. We don't understand what is going on inside its head, right? We don't always understand that. And that's a topic that we'll discuss in episode 18. But in the moment, right, what we do know. So I mentioned that because I don't want anyone to go on with the intuition like this addition is all that happens. No, that's not all that happens. You see, in very complex neural networks, right? For example, in systems like ChatGPT, you would hear statements like 70 billion parameters, 180 billion parameters, 60 billion parameters. What they are telling you, some will even mention as high as 1 trillion parameters, like Kimi K2 models, ChatGPT models are also in trillion parameters, Claude models. What exactly is going on there is we are saying that for every input, and this is not a matter of one input. No, when you are dealing with systems like ChatGPT, with all those long prompts that you send, your inputs are also divided so into layers. So this is our input layer, right? Inputs, layers. And then when you hear billions of parameters, we are telling you that. Remember when we said hidden layer? In some systems, you have so many hidden layers. So yes, you can have multiple hidden layers before you actually get to your output layers. This is not compulsorily important now, before you now get to your output layers. So what's happening here is when we send the input first goes to all of the hidden layers. And this is probably an image you are familiar with, which I will not really go into explanation right now. But just know that for everything that's happening here, there are weights, right? This layer might be checking ear. This layer might be checking eye. This layer might be checking nose. This layer might be checking teeth. And this layer might just be checking what? Legs. So when you send information that this layer approves, is it ear? If our threshold was 0.5 and it got 0.4, by the time you're sending it down to this layer, it will tell it 0. Don't output yes. No, it's not good enough. But if that's, say, this part got 0.68, it will go, it will output that. And once again, this is just intuition because so many things go on inside neural networks that machine learning research has not still been able to identify. How does it think? How does it divide the task? How does it even find the answers? We don't know. But this is intuition enough for you to know that when you send a message into your AI systems, your ChatGPT or your Claude, just know at the back of your mind that your message is being converted into numbers. Your number is being multiplied by weights. Your weights is then added with the numbers, and then it is given out as an output. And the good thing is, when your output comes back to you, output is coming back as what? Text. Yes, it's coming back as text because your output model, your output layer actually receives numbers too, right? It actually receives numbers too. But then there's a system that converts this number back into text for you to fully understand. Okay, next episode, we're going to discuss what happens when we add all of these layers, right? All of these layers, we're going to discuss that. And this is also saying that we are going deep. We're actually going deep into the model. So episode 10 is where we're going to explain deep learning, right? Deep learning, where we're going to talk about how multiple layers, multiple hidden layers, right? How they actually help systems to grow. This is the reason why your systems like ChatGPT can answer your questions today. This is the reason why AI went from interesting to like boom, world changing, right? So in episode 10, we're going to be discussing deep learning. I understand that this episode might have been quite, complicated a bit. And I hope it was also understandable because I try to break it down a lot. But this is not one of the easiest things to explain in artificial intelligence. And by next week, I'm going to do a lot more examples so that it can be very easy to understand. But I hope you actually got the intuition of what's going on at the back of your systems. And next time when you type a prompt into ChatGPT, see numbers, see weights before you see the outputs. See you in the next episode.